So if you work with robotics, you'll probably come across this board. And what this is a servo driver that can drive 16 PWMs made by Adafruit, and this is a clone version. Now I decided to make my own, as you've seen in the previous videos, and if you haven't, please go ahead and have a look. I then designed this PCB. We take out the tweezers. I brought these tweezers just for this video. Tell me if you like it or not. So here we have the chip that is responsible for providing up to 14 amps. Got two of these in parallel. So if you do the math, that's 14 plus 14. And they power these three servos here and three here. It did have some ESD protection. I can just focus the camera. Right, here we go. Got some ESD protection here that I took off. And these then go into this connector, which then connects into this main board. That you have two of these, so one here and another one here. And that then go into this TNZ board, right? And here are all your PWM pins, 14. Which made me have quite a few PCBs. So I changed it up and I made this board, which again is the TNZ board with all your PWM inputs. Got 4 PWM outputs per channel, so each channel can do up to 14 amps. So you got 1, 2, 3 and 4 of those. So you got 4, 8, 12, 16 PWM pins, and each can do up to 14 amps. Right, so here we have some clever USB power management. So if you plug in the USB and a TNZ 4.0 is powered, it will take power from here. But if you power both of them, but if you only power it from the USB, it will take its power from here. And this super tiny chip decides where the TNZ takes power. Is it from the mains or from the USB? Right. So I'll populate the board and let's see if I can get this to focus. Here we have it. So I've got these diodes placed for the back EMF, and I've put these heat sinks on there. Now in one hopefully final design, I'll put these heat sinks right here, and that's under the inductor instead of this, for better heat management. I did have the TNZ board here, and I had a connector here for the Wi-Fi. I was going to use an ESP32 but then I had this brilliant idea where instead of the TNZ board I can use an ESP32. So that will come in the next video. However, that's the tiny chip that decides where the TNZ board gets power. I've added these extra pads for the capacitors in case I needed any. Now in the new board, I'll replace this with an ESP32 and take away these capacitors. So still have a 90 by 90 board, have these diodes in place, and I'll have on the other side, I was thinking of having some temperature sensors so I can measure the temperature, then add a PWM connection out that goes to a fan where it can sense the heat of the PCB and then turn on the fan using an N-channel MOSFET. And hopefully that will be the final board. You've got your 4S going in, 5 volts, 14 amps per channel. You've got 4 channels, so you can calculate that it goes to 56 amps, so it can generate quite a lot of heat. Let me know in the comments how I can make this board better. Any suggestions? Appreciate it. Right, moving on to the robot. Now the issue with this robot is that it's got these legs. They're alright, but they're still a bit wobbly. I can increase the tolerance here and make it a bit more stable. But I was also thinking making this a bit more stable. This is all 3D printed, and then sits underneath here. It's currently on the stand, as you can see. It's on this stand. And the idea is that I'll make this PCB as the last version, and I'll make some mechanical updates. Put my fan here with the N-channel MOSFET controlling it through PWM. Make some final changes, and then I can program the robot over Wi-Fi. Now all the inverse kinematics have been calculated for this robot. I'm not sure if I should open source all of this or not. Let me know your comments and any suggestions you may have.